let's look at another special angle. Let's say we have, I don't know, maybe the 30 degree. So let me just draw a little picture here. So let's say we're at 30 degrees now, okay? 30 degrees. Let's see what the coordinates of that would be on our unit circle. And again, we're dealing with the unit circle. So our radius is 1. So basically our x and y can translate directly to cosine theta and sine of theta, okay? So let's say we have this triangle here. And how are we going to figure that out? That's kind of weird, right? So let's say we have this triangle, and I'll just blow it up for us. So this is 30 degrees. Right? Right here is 30 degrees. We know our radius has a length of 1 because we're dealing with the unit circle. Okay, so this is a length of 1. This, conversely, is going to be 60 degrees here. So we have a 30, 60, 90 triangle, right? So that means that the like short leg, or this short side leg length, is going to be 1/2. Okay? And we can also see this. Let me go back a couple steps. We can derive this because, and this is just for background information, if we were to attach another little triangle on there, kind of just flip it down, reflect it, right? So if we have another 30 degrees there, we have 60 here. So this is an equilateral triangle, right? Because 30 plus 30, in total on the left side, that's an angle of 60. So we have to have a length of 1 all the way around, right? Because it's equilateral and equiangular. So if this is 1 and we have to split it up in between each of these, this has to be 1/2 there, okay? So again, if we go back to our single 30, 60, 90 triangle, we have 30 degrees here, and that corresponds to the short side leg, so that's a 1/2, and 60 is there, and then this is going to be, just by the 30, 60, 90 configuration, we have a square root of 3 over 2 there, because this longer side leg is automatically radical 3 times whatever your short leg is. So that would be radical 3 times 1/2, which gives us that radical 3 over 2, okay? So, the point to this whole thing is saying that, okay, so when we have this triangle, then our coordinates are going to be radical 3 over 2, comma 1/2. Alrighty? So that means that our cosine of 30 degrees is going to be, so that means like the x-coordinate, how much we go this way, that's going to be radical 3 over 2. Okay, ignore that 1 up there. And our sine of 30 degrees, how much we go up, right, in the y direction, that's just going to be a 1/2, okay? Alrighty, so there we are. Kind of complicated, but we made it. So this, again, this is always true. This is always true, no matter what radius you have, okay? And let's say, we'll explore one other thing on the next slide. So let's say now we have our unit circle again, okay, and we're dealing with 60 degrees, okay? So this is 60 degrees here. Let me blow this up a little bit so we can see what's going on. So let's say we have something like that, right? And here's, wait, hold on. Here's 60 degrees, okay? So this angle is 60 degrees. Now what do we do? Like, what are the coordinates of this? What are our sine and cosine of 60? Well, we could draw a triangle like this, okay? And we could say, well, this is y, this is x, right? And again, up here we have 30 degrees. And this is a right triangle. So the hypotenuse is going to be 1 because we're dealing with the unit circle. Unit circle. Okay? And we have kind of the same relation, right? This 30, 60, 90 triangle. So if we have something like this is 60 this time. So this is 1, and our short leg should be 1/2, and this should be 3 over 2. So in this case, our point's going to be 1/2, comma, radical 3 over 2. Okay, so this tells us our cosine part, and this tells us the sine part. So cosine of 60 is equal to 1/2, okay? And sine of 60 is now equal to radical 3 over 2. Okay, so if you ever get confused, so this is what we've gotten so far. Let me write a summary on the next slide. So we have, if we're at 45 degrees, also known as pi over 4, then we have something relating to both our cosine and sine. Cosine and sine are equal to radical 2 over 2, okay? If we're at 30 degrees, which is also the same as saying pi over 6, then our cosine is equal to, well, cosine is then equal to radical 3 over 2, and sine is equal to, of those angles, is equal to 1/2, okay? If we're at 60 degrees, then we're at pi over 3, our cosine is now equal to 1/2. So they kind of switch, and sine is equal to radical 3 over 2. So we can tell what this is if you just had to guess, kind of. So whenever you have 45 degrees, any multiple of 45, we know it has to involve this value of some sort, okay? When we venture into the other quadrants, such as quadrant 2, quadrant 3, and quadrant 4, all of these values just either differ by some kind of sign. And by sign, I mean not like this kind of sign, but this kind of sign. Sign, like as in positive or negative, okay? So for example, if we had some angle like this, which is 135 degrees, okay? That's some kind of multiple of 45, right? So we're going to have some kind of radical 2 over 2, radical 2 over 2, except for now the x value is just negative. That's it, because x is now on the negative side, right? On the negative x-axis, okay? And as for 30 and 60 degrees, so here's 30 and here's 60, we can kind of tell it's going to be some combination of radical 3 over 2 and 1/2, right? They just switch in some way. But how do you tell which one goes where? Well, we can just keep in mind that radical 3 over 2 is always going to be greater than 1/2. So you can see, for example, for 30 degrees, when we're here, then we could see we travel more in the x direction than the y direction. So that tells us, okay, so our x has to be this guy, and our y has to be this one, okay? Whereas if we're at 60 degrees, then we see that we go more up than we do go to the right. So that means that our y value has to have this radical 3 in it, and the other one is going to be 1/2, okay? Okay, so here it is, the unit circle, right? So I made it all dramatic and said behold and everything, but, and it is something to behold, really, right? It's quite a sight, because there's so many numbers, first of all, and it's like, wow, okay, do I have to memorize all of that? And the answer is no. At most, you'd probably have to memorize what's in quadrant number 1, because everything else is kind of symmetrical. That's the great thing about the unit circle, is that there is lots, and I mean lots, of symmetry. And that means that we're just going to reuse certain values, such as square root of 2 over 2, square root of 3 over 2, and 1/2. We're just going to write different configurations of those, different arrangements, and just put signs on some, like positive sign on some and negative sign on another. You just have to tell which quadrant you're in, right? And yeah, that's pretty much it. So all you have to know is really quadrant number 1, and then you can kind of extend your knowledge in order to figure out the sine and cosine values, or the x and y values, at other angles as well, okay? And the really nice thing is that once you're familiar with the unit circle, once you know sine of a certain angle and cosine of a certain angle, given the unit circle, then we can figure out the xy coordinate of any point on any circle. Okay? Coordinates of any point on any circle, centered at the origin, that is. Centered at origin, which is just 0, 0, by using the following, that x is equal to r cosine of theta, and y is equal to r sine of theta. Okay, so then our xy coordinate would just be r times whatever cosine theta is, which we would know already. We would just know the cosine theta part from our unit circle, and then we could also say r sine theta would be our y coordinate, and we could figure out sine from using the unit circle. Okay, so here's a question. It says to find the coordinates of the point on a circle of radius 12 at an angle of 7 pi over 6. So they give us our angle in radians. So theta is equal to 7 pi over 6. So the point on our circle, our xy coordinate, is going to be equal to r times cosine theta, and then comma r times sine theta. Okay, and in this case, our cosine theta and sine theta are going to be cosine of 7 pi over 6, so we want to figure that out, and sine of 7 pi over 6, okay? So our job is going to, because we already know r is equal to 12, okay, so we could just plug that in there. We need to figure out what is cosine 7 pi over 6 and what is sine 7 pi over 6. So to do that, we're going to take a look at our unit circle. And we're going to say, okay, so this is pi over 6, 1 pi over 6, and I usually count by pi over 6s. So here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, and 7 pi over 6. Here it is. Okay, so 7 pi over 6, that's basically 30 degrees from the negative x-axis, right? And so we're going more in the x direction, in the negative x direction, and then we're going to go a little bit in the negative y direction. So going more in the negative x direction gives us this negative radical 3 over 2, and a little bit in the negative y direction gives us this negative 1/2. Okay, so this is cosine of 7 pi over 6, and this is sine of 7 pi over 6. Alrighty, so now we can formulate, go back to our problem and say, okay, so our xy point is going to be 12, which is our radius, times cosine 7 pi over 6. And cosine 7 pi over 6 is this negative radical 3 over 2, comma, r again, which is 12. Sine 7 pi over 6 is a negative 1/2. Okay, and then we just simplify here. So we can say now our point is going to be negative 6 radical 3, comma, negative 6. Okay, and that is going to be our point on the circle of radius 12 at the given angle. And a final note to make is that calculators, okay, so here's an important note to make, is that calculators oftentimes have a degree, DEG, or radian, RAD, mode, in which you can switch between degrees and radians. You can switch your calculations, so be careful. So basically just be careful, because oftentimes, well, not oftentimes, but sometimes, just because of this mode and everything, then you can be confused when you like type in cosine 30 and get some random weird answer. If you meant 30 degrees and it was on radians, then you're definitely going to get a different answer. Okay, so just be careful with that. Make sure you're on the right mode for the units that you're working with. Alrighty, so that concludes the concepts video on the section on points on circles using sine and cosine. I hope that helps, and I'll talk to you in the practice problems video if you watch.